While you keep learning, you are alive. Hello everyone and welcome back. In this video, I intend to discuss another part of the program controller structure in Python, which involves loops. Specifically in this video, I'll be talking with you about while loops. Given that we previously explored the if statement and for loops in other videos, you are now fully prepared to become familiar with this topic, namely while loops. The while loop comes in handy when you want to repeatedly execute a block of code as long as the specific condition is true. For better understanding, let me explain the concept further with a scenario. Imagine you're a network engineer assigned to keep an eye on a crucial network connection for possible problems. You aim to utilize Python to regularly examine the connection status and trigger alert if any issue are identified. Okay, here's the scenario. Now, what should we do? Well, let's try to define the overall structure of our code using what we have learned so far. According to this scenario, we need to monitor the critical network link. So, what does that mean? Take a moment to think about it. Okay, it means that first we need to identify the critical link, right? Now, let's assume that in this scenario, the internet link is critical for us. Then, to specify this link in the code, we need a variable, right? After that, we need to write code to monitor it. Writing this code can be a separate part of our work because we might to check different conditions for monitoring that link, correct? So, it's better to write it in the form of a function. Therefore, we need a function. What else do we need? Pause the video and think about it. Okay, if you watched the previous videos, I'm sure you guessed it right. Okay. Let's write it up to this point together, and as we write this code, we'll add the remaining parts step by step to complete our code. Are you ready? Let's get started. All right. So now we need to create a variable and specify the internet link like this. Let's say link to monitor equals. Do you agree to use a public IP as the value for this variable? Just like when you want to check the status of the internet link using IPSLA in a router, you can specify a public IP as a target, right? Here, we're doing the same. For example, let's use, let's say 8888. That's it. Now, let's move on to the function. This function is supposed to check the status of the link, whether it's up or down, and take some action accordingly. For example, it checks if the link is up, it returns the value up to us like this. Let me define our function using def check network, let's say link status. There we go. Now let's indent this variable to be inside the function. Okay. Very good. So far, we have created a variable and a function as planned. But we haven't told the function what it should do yet. Let's ask it to ping the address 8888 for us, and if it gets an echo reply in response, it should return the value up to us. But who should pinging this address? Well, obviously Python. But how should Python do this? It's better to ask the operating system to do it for us. Oh, it's getting complicated. Writing such code means establishing communication with the operating system, telling it what to do and operating the results, and then using it in this script. It requires a high level of knowledge and skills, and we're just at the beginning, right? Yes, that's absolutely correct, but we don't need to write such code ourselves. This code exists in Python as a built-in module, and we just need to call it and use it. But how can we call it? It's straightforward, just like this. Let's say, on top of my code, import OS. I will explain about importing and using modules in Python in future videos when the time comes, so don't worry. But let me briefly say that the OS module allows us to communicate with the operating system and ask it to perform many tasks that we need, tasks related to the operating system. My friends, you should know that in the field of networking, Python has many diverse and useful modules in the area of automation and programmability. We'll be working a lot with those modules. Well, let's not get too involved in the discussion. Now, using one of the functions of the OS module, the system function, we ask the operating system to ping our desired address like this. Let's say os.system ping with a space plus what? Okay, plus this variable, link to monitor. As you can see, the variable link to monitor contains 8888. Now, to access the output of this function in the continuation of the code, I assign it to a variable like this. Let's say response equals os.system, blah, blah, blah. That's it. Now, we need to examine the result of the output. In other words, if the ping result is an echo reply, return the value up to us. In the next part of the code, we need this up value, okay? So we check it with a condition like this. Let's say if response equals 0. Now the variable response, as you can see here, contains the output of the os.system, or in other words, the result of the ping. But what does response equals 0 mean? If you have followed our videos, you surely know. I explained about this in a previous video that you can see the link to above. However, let me briefly say it again. Here the number 0 is the same as the type code 0 in ICMP, and type code 0 represents echo reply. And you know what, my friends? Python knows this using the OS module. You see how simple our work has become? Excellent. Now we need to tell it to return the value up. In this case, return up. Very good. This is our function. Now, what else do we need? Let's see together. Stay with us. All right. We've covered part of the requirements stated in this scenario. In fact, we've written code to check the status of our important link using ICMP. Now, we need to specify what should happen if the link, based on the condition we have set, is not accessible or encounter a problem. And what should happen if there's no issue? To keep things simple, for now, we want Python to give us a message in both cases. This means it should go check the link status as we specified and then return the result to us in the form of a simple message. Very simple and easy. But let's make it a bit more professional. Let's ask it to check the link status multiple times for more assurance and a more accurate result. That way it's better, right? All right. For this task, we need to first specify the number of attempts it should make to check the link. But before that, let me cut this variable from here and put it in right place. And there we go. Here we're done with our function, so let's exit from function and write the rest of our code outside the function. Okay. So we need a variable like this. For example, max attempt equals, let's say, 3. We're asking it to try 3 times. Now, let's write a comment for it, like, let's say, set the maximum number, let's say, to number of attempts. It's better. Attempts to check the link. We say try 3 times, right? In fact, we define a counter, so it needs an initial value to increment, okay? For this, we need another variable, like, for example, attempt equal 1. And let's add a comment to clarify what we are doing, like, let's say, initialize, let's say, initialize the attempt counter. Very good. Now, we need something to take care of the execution, monitoring, and scheduling of events. In essence, it should go and do what ultimately needs to be done. You know, somewhat similar to an object tracker in IPSLA. The supervisor and executed we need are actually the while loop here. Ready to go for it? Great. For a better understanding, let's first write a meaningful and comprehensible command like this. For example, let's say use a while loop to what? To continue continuously check the network link. Let's say it's up or the maximum attempts are reached. How about that? Use a while loop to continuously check the network link it's up or the maximum attempts are reached. Is it understandable? Great. Now, let's move on to the while loop like this. While true. And a colon that indicates the while block. But wait a moment. What does while true mean? Here's the point. Allow me to explain. My friends, after the keyword while, depending on your needs, you can use almost any logical condition. For a better understanding, take a look at this code I wrote earlier. And the first example that you see here we are dealing with an infinite loop. Here, I assign a value to the variable a. And as you can see, as long as the variable a has a value of any type other than 0 and false, the code under the while is executed. Note that it's usually better to have a condition to end the loop because an uncontrolled infinite loop can lead to code or system crashes. I say usually because exceptions exist. Now, let's run it and see the result. As you can see, the statement A has a value, is repeated endlessly, and if I don't stop it, it continues indefinitely. Now, I'm commenting out this code, so it won't run, and let's move on to the next example. As you can see, let me comment it. There we go. As you can see, in the second example, I assign an initial value to the variable x, which is 1. Here, right after the while keyword, I identified a logical condition. In this case, when I run the code, the while loop displays the value of the variable x at each iteration. Then, as we requested, it adds 1 to it and continues until it reaches the number 11. It stops when it reaches 10 because that's what we asked for in our condition. Let's see it together. As you can observe, it shows us the output from 1 to 10. Okay. I want to point out a more concise and professional way to increase the value of the variable x in each iteration. I did it as x equal x plus 1. But this can be written in a better and more professional way, like the line below. Let me uncomment it and comment out the previous line. First uncomment it and comment the previous line. Here, I wrote it in a more concise and professional way using x plus equals 1. My friends, in conclusion, the output of both approaches is the same. It's just that the second line is more concise. This method, known as augmented assignment, is a brief way to perform arithmetic and bitwise operations on a variable and then assign the result back to the same variable. Great, let's continue with the third example. In this example, I want to illustrate the use of the break and continue keywords. As mentioned in the previous video, these keywords are also applicable to the for loops. As you can see, the code until just before the if statement is exactly the same as the previous code. Here, in the if block, I specify that if the value of the variable x becomes equal to 7, the loop should stop. I achieve this using the break keyword. So, as soon as the condition is met, the loop stops. Let's see it together. As you can see, this loop repeats only 6 times. Okay. I'll comment this one out. Now let's see the usage of the continue keywords. This example is almost identical to the previous one, with the difference that I placed the print function after the continue. This keywords proposed is to ignore. In other words, in this example, using the if statement, I specify that if the value of x reaches the number 4, disregard displaying that number and continue the loop. Let's see it together. As you can see, numbers from 1 to 11 are displayed except for number 4, as was specified in the condition. But why 1 to 11? Well, it's entirely logical. In each iteration, the loop adds 1 to the value of x until it reaches the condition we set, which is the number 4 in this case. Due to the presence of continue in the condition, it skips displaying the number 4 and prints the next value. However, one crucial point to note is that the continue keyword skipped the number 4, not the 4th iteration, my friends. In fact, the 4th iteration happened, and the result was skipping the display of the number 4. Okay? If you pay attention to the output, you'll see that our loop has only repeated 10 times, meaning our condition while x less than 11 is working correctly. Here the number 4 is removed, making room to display the number 11. Essentially, a very important point here is that we specify the number of loop iterations in this example. The actual numbers are not important here. Another thing to note is that to display the number 1 in this example, I set the initial value of x to 0. If I set it to 1, like in previous example, given the location of augmented assignment, and the first iteration, the value of x would become 2. And you would see numbers from 2 to 11 in the output. For a better understanding, I recommend practicing all these examples after watching this video. Try making changes, observe the results, and analyze them. If you come across anything interesting, share it with others in the comments. In the fourth example, I want to introduce you to the else block in a while loop. The else block serves a general purpose everywhere. It's a conditional check and execute code if the condition is not met. We have encountered the else block in if statements and for loops before. Here, I set the initial value of x to 1, similar to example 2, asking it to display the value of x in each iteration and add 1 to it each time. If we execute the code without considering the else block, like in example 2, the loop will iterate 10 times, displaying numbers from 1 to 10. Let's see it together. Here is it. However, to give our code more meaning, I added the else block in this example. For a better understanding and using fstrings and the print function, I asked it to display this sentence in the output. Now, let's run it again. As you can see, the else block has also been executed, indicating that variable x now holds the value 11. But what happened? Let's step through it together for a better understanding. Step 1. The variable x start with a value of 1. Step 2. The while loop checks if x is less than 11. Since 1 is indeed less than 11, the loop runs, okay? Step 3. Within the loop, the print x statement displays the current value of x, which begins at 1. Subsequently, the variable x gets increased by 1 using x plus equals 1, okay? Step 4. The loop persists until x reaches 11. Once x becomes 11, the loop condition, which is x less than 11, becomes false, directing the program flow to the else block, right? And finally, step 5. The else block prints a message that incorporates the final value of x, which is now 11. My friends, the else block in a while loop is executed if the loop condition becomes false, indicating that the loop has completed its normal iteration. In this case, it's used to print a message indicating that the value of x has reached 11 after the loop completes, okay? All right, and finally, example 5. In this example, I want to introduce you to another logical condition in the while loop. My friends, while true creates an endless loop, just like example 1. In this case, as long as the condition true holds, which is always true, the loop continues its work unless we use a break statement or close the program to terminate it. Practically, we use while true when we want the loop to continue until a specific condition inside the loop becomes true. We can then exit the loop using break, just like this example you can see here. Here I simulated the privilege mode of a Cisco switch environment. But how did I do this? As you can see, very easily. By using the built-in and widely used input function. This function receives input from the user, essentially reading lines from the user and returning it as a string. Note that I said a string. So if we want to receive inputs of various types from the user using input function, we first need to convert it from a string to the desired data type. I'll explain more about this when the time comes in the future videos. Now, If you pay attention to this code, you'll see that the loop continues until I use the word exit. Let me run it and see the result together. Okay. As soon as the program is executed, the text inside the input function is displayed. Here you can see it, the switch, waiting for me to enter input. Here I can enter anything, even just print enter key. As you can see, the program continues its work, and it doesn't care about my inputs unless the condition I wrote inside the loop becomes true. In other words, if I enter the word exit according to the condition I defined for it, the loop will stop. Let's see. Of course, I can give it any other condition. For example, ask it to change the prompt if I enter configure terminal or I don't know, anything else. But for now, I don't intend to complicate this discussion, so I'll stick with this value. Alright, so far that's enough. Now that you're somewhat familiar with how the while loop works, let's get back to our scenario. By now, you know what while true means, okay? Now, but inside the while loop, we need to call what? Call the check network link status function and ask it to do its job based on the conditions we have specified, okay? Like this. Let's say check network link status. Okay. And now, to be able to refer to it later in various places, I need to store its results in a variable. So I create a variable, let's call it, for example, link status equals this function. Okay. By doing this, as long as the program is running, this function keeps doing its job. But according to our scenario, if there is or is a network connection, the program should give us a message to keep us informed, okay? So we need to add some conditions to the program. First, let's check what to do if the connection is established, like this. Let's say if link status equals up. Where did this up come from, and what does it mean? Right. This is conditional output we define in the function. It means if the response variable contains ICMP type 0, which is an echo reply, it indicates that the connection is established. In this case, what should it do? Let's ask it to display a simple message. Print. Let's say network link is up and no further action needed. It's clear enough. There we go. And after showing this message, let's instruct it to stop the loop like this. Break. Simple and easy. Okay, now it's good to write a comment for this condition to make it clearer, like, let's say, check if the link is up. And another comment for the break statement, exit the loop. Nice and easy. Now, if the connection is not established, what should happen? I mean, if the response variable doesn't contain ICMP type code 0 and the check network link status function doesn't return up, what should it do? Well, it should give a message like network link is down or something similar, right? So we need to check this condition as well, but here's a question. Is it necessary to use if again? Well, not necessarily. Why? Because in the if block, we use break. So as soon as the condition is met, the corresponding message is displayed, and we exit the loop. Therefore, we just need to exit the if block and use the print function to display the next corresponding message. And we no longer need to explicitly write an else block or other if block, you know? But here's the point. We decided to check the link status more than once for accuracy and better performance. Make sense? So let's format the message we're going to display using fstring to show how many attempts have been made like this. Let's say print fstring alert, and let's do this. Network link is down, and not down, and attempt variable, and guess what? Max attempt variable, okay? There we go. But before I continue my explanation, let me add a comment for this section like this. Let's say if the link is down, what should happen? Print and alert. Oh, and what? And check again. Let's explain it clearly. Up to maximum attempts. What about that? Now, it's clearer, okay? All right, here, if the network link is not established, using print and fstring would display the corresponding message and specify which attempt out of max attempt it is. Okay, makes sense? But something is missing. What is it? Pause the video for a minute and think about it. Got it? Yes, the initial value of attempt is 1. And to reach max attempts, we need to increase it in each iteration. So let's add a command for that. Increment the attempt counter. Now, let's increase the value of attempt like this. Attempt plus equals 1. How about that? One more small thing is left. We need to specify what should happen if we reach max attempts. Obviously, in this case, the link is lost, and we need to not only display a suitable message, but also exit the loop and figure out how to restore the connection, like this. First of all, let me type a command. Check if the maximum attempts have been reached. Okay. And the condition is if attempt greater than max attempt let's say print maximum attempts reached and what? And let's say unable to establish a connection. Max attempts reached, unable to establish a connection. Okay. And finally, break the loop. Exit the loop. This code checks whether the number of attempts has reached the maximum allowed attempts. If it has, it prints a message indicating that the maximum attempts have been reached and that's unable to establish a connection. Afterward, it uses the break statement to exit the loop. Okay? All right. Let's run the code and see the result. Okay, as you can see in the output, our connection to the internet is currently established. So the program displays the message network link is up, no further action needed, and then a stop. Great. Now I disconnected my internet connection and let's run the program again. You'll observe that the program, based on the number of attempts specified in max attempts, in this case 3 attempts, check the link status. Since it concludes in the third attempt that the connection is indeed down, it shows the following message. Alert! Network link is down. Attempt 3 out of 3. Maximum attempts reached. Unable to establish a connection. This indicates that the program attempts to establish a connection 3 times, but it couldn't, and has reached the maximum allow attempts. Okay? But here's a question. Is there a better and more comprehensive way to deal with this scenario, or in general to intelligently manage networks? Yes, absolutely. The key is to learn network automation and programmability thoroughly by mastering tools related to this field, such as Python, Ansible, and other methods I'll discuss with you soon. We can design, implement, and manage our network in a smarter and, let's say, more efficient way. This allows us to handle traffic optimally without stress, worry, or unnecessary hassle, even redirecting it to other links before anyone notices. Of course, this is just a small glimpse into the world of network automation and programmability. Okay, great. With this explanation, we have come to the end of this video. If you find it helpful, please consider subscribing and turning on notifications. This way, you'll stay updated on our upcoming videos. If you like this video, giving it a thumbs up and sharing it will contribute to reaching more people interested in this topic. Thank you for your attention to this video.